if I try to repeat what I said, this HCl molecule is linear and asymmetrical. What's the meaning of this asymmetrical word? We had to say like this. Let me remove this first. The molecule is linear and symmetrical. In other words, the dipole moment in the bond does not get cancelled. Remember, if the dipole moment in the bond does not get cancelled, that molecule is called asymmetrical. Similarly, if I go to this carbon dioxide molecule is linear. It is the same as HCl molecule. It's a linear molecule because it has only 2 bond electron groups and no lone pairs. So carbon dioxide molecule is linear. And we call it symmetrical. And it is symmetrical. What is the meaning of it? Carbon dioxide molecule is linear. Linear and it is symmetrical. What's the meaning of symmetrical? In other words, the individual dipoles get cancel each other. Carbon dioxide molecule is linear and it is symmetrical. In other words, the individual dipoles get cancelled. We can say, as a result, carbon dioxide molecule is symmetrical and has no overall dipole. You must remember this terminology very well. I'm going to the next part of the discussion. Probably I can give you a few seconds to take a picture, take a snapshot. Why HCl molecule having individual dipoles shows overall dipole. Why carbon dioxide molecule having individual dipoles do not show overall dipole? Because in carbon dioxide case, individual dipoles are going to get cancelled out. Remember, dipoles can get cancelled out if they are equal and they are in opposite directions. Here, dipoles are not in opposite directions, so therefore, see this difference. Okay, we can go to the next part. Discuss whether the following molecules show overall dipole or not. Remember, children, it will be very difficult for you to attempt this question if you have no idea about constructing shapes of molecules. Actually, you should have a very clear idea about dot cross diagrams and shapes of molecules before we start this work. You will see how important it is to know these concepts of dot cross diagram and shapes of molecules when it comes to the discussion of this. You see, discuss whether the following molecules show overall dipoles or not. Discuss whether the following molecules show overall dipoles or not. We have discussed dot cross diagram of ammonia, and you are supposed to know it. But anyways, quickly I can figure out in this manner. NH3 means hydrogen, nitrogen, hydrogen, another hydrogen. Because nitrogen is from group 5, it has 2 electrons remaining here. So the shape is pyramidal. We start to work with this pyramidal. Mm, nitrogen hydrogen bonds. Nitrogen hydrogen bonds show dipole moment from hydrogen to nitrogen. The reason why I say there are um, dipole moment from hydrogen to nitrogen is because the electron attraction is happening from hydrogen to nitrogen. Nitrogen is more electronegative. So again, nitrogen hydrogen bonds show dipole moment from hydrogen to nitrogen. And then I write the shape of molecule. The shape of molecule is pyramidal. Shape of molecule is pyramidal. Not pyramidal, pyramidal. Shape of molecule is pyramidal. And the individual dipoles do not cancel out. Cancel out because we can see because the ammonia molecule, because ammonia molecule is asymmetrical. Nitrogen hydrogen bonds show dipole moment from hydrogen to nitrogen. The shape of molecule is pyramidal, and the individual dipoles do not cancel out because the ammonia molecule is asymmetrical. Asymmetrical. Okay. So this is the answer we can write for ammonia molecule. Now we can go to water molecule. It is better if you do this diagram also. Nitrogen, hydrogen. If you show the pyramidal shape, one hydrogen comes here. Another hydrogen goes there. There's a lone pair of electron. From nitrogen to hydrogen, there's polarity, delta negative, delta positive. I'll take a red color for that. Again, delta negative, delta positive, delta negative, delta positive. So there's an overall dipole towards the nitrogen side from hydrogen. Delta negative, delta negative. This is the overall bond polarity. We go to the next one. Water molecule. Water molecule is hydrogen, bond, oxygen, bond, hydrogen. Two electrons there, two electrons here. What is the shape of this molecule? The molecule shape is bent. Lone pairs here, lone pair here. And there is delta negative, delta positive charge separation between oxygen and hydrogen. On the other side, also delta negative, delta positive. So there's an overall dipole from hydrogen to oxygen. Delta negative, delta positive. So we can write the answer over here. I will take the same thing that I have written for ammonia molecule to water molecule, and I modify that. We'll see. We can say oxygen hydrogen bonds show dipole moment from hydrogen to oxygen. The shape of, I'll write water molecule. The shape of water molecule is bent. And the individual dipoles do not cancel out because of water molecule. Because the water molecule is asymmetrical. Dipole show the shape of water molecule is bent, and the individual dipoles do not cancel out because the water molecule is asymmetrical. Again, we can say one more sentence. Water molecule shows overall dipole. Water molecule shows overall dipole. Don't take down. I will discuss the other one also. All right. Let me explain this. Our next molecule is CCl4. CCl4. CCl4 molecule is a tetrahedral molecule. We have carbon, hydrogen above, not hydrogen, chlorine. One chlorine there, one chlorine here, one chlorine here, one chlorine here. It's a tetrahedral molecule. In this tetrahedral molecule, delta negative, delta positive. I'll write like this. Delta negative, for that I'll add one more plus here. Delta negative, one more plus here. Delta negative, one plus over here. It's a tetrahedral molecule. There are no overall dipoles. We'll see what we can write here. This is chlorine hydrogen, chlorine carbon. Chlorine carbon bonds show dipole moment from carbon to chlorine. The shape of CH4 molecule. The shape of CH4 molecule is tetrahedral. And the individual dipoles cancel out because the CCl4 molecule symmetrical. And we can say CCl4. CCl for molecule shows no overall dipole. Okay, take down these three answers and then see whether you can do this CH2C, CCl2 work. Take few minutes and see whether you can do this work. I think we can talk about this next molecule. As I said, even if you don't have dot cross diagram for this, you should know the structure of the molecule. This is CH2CCl2. I don't want to talk about the name of it. We will discuss it in organic chemistry lesson. Roughly, if I talk about the shape of it, it's a planar molecule. When I say planar, let me take green color for this. Yeah, green. This molecule having a carbon-carbon double bond is a planar molecule. This planar molecule, let me do like this. Okay, this is a plane. In this plane, let me use black for two carbon atoms. This carbon atom on the left-hand side and the other carbon on the right-hand side. They come in the middle. Carbon, carbon. Between them, there's a double bond. On the left-hand side, we have two hydrogen. These two hydrogen atoms, I can do one over here, the other one over here. And two chlorine atoms are there. Okay, one chlorine here, one chlorine here. We don't think about difference in polarity between carbon and hydrogen because it's a very, very slight difference. But between carbon and chlorine, there's a very high electronegativity difference. So you will see a delta negative charge on the chlorine and delta positive charge on the carbon for that. And one more delta negative charge on chlorine and positive charge is added for that on the carbon. So if you think about this molecule towards the chlorine atom, okay, in this molecule towards the chlorine atoms, the two chlorine atoms, there's an overall dipole, delta negative, delta positive. So its molecule is asymmetrical. It shows an overall dipole. The explanation is this. This time it's not OH. We are talking about carbon chlorine. Carbon, you can copy down this. Carbon chlorine bonds show dipole moment from carbon to chlorine. We don't talk about the shape. The molecule is planar. The molecule is planar. And the individual dipoles do not cancel out because the molecule is asymmetrical. You can see it shows overall dipole. Please know how to identify a molecule, if it has dipole or not, and how to explain. Always we have to talk about cancellation of dipoles, and symmetrical or asymmetrical nature of a molecule. Those are the terms to be used in your explanation. I'll give 1 minute to complete this.